In this video, I'm going to show you a slightly harder example of manually annotating and correcting protein coding genes after getting the web server files from Mitos. The first thing we're going to do is open up our config1.fas file in a text editor of our choice. I'm going to be using Text Wrangler. And also open up Xpasi Translate on any web browser. I'm going to set it to verbose just because I think it's easier to read. And then we're going to set this to invertebrate mitochondrial, since that's the type of genome that we're working with. Next, I'm going to open up Mega, click Align, Edit/Build Alignment, retrieve sequences from a file, and click OK. We're then going to navigate to the file that we originally uploaded to Mitos, this FASTA file. This is going to open up our entire genome for viewing. The gene that we're going to be looking at in this case is going to be COX3. So we're going to navigate to where Text Wrangler says that it starts 3269. If you just type down here 3269, it'll bring you here and highlight the first nucleotide of the sequence. So let's assume that we have already manually annotated all of these protein coding genes, COX1, COX2, ATP8, ATP6, and we've decided that this start codon, starting at 3269, is going to be the actual start codon of the sequence. We're then going to highlight all the way until the end of the sequence, which is going to be 4054. Once we're there, go ahead and copy it using Command-C if you're on a Mac or Control-C if you're using a Windows PC, and paste it into Xpasi and hit Translate. We can see that we have a typical start codon, but we have no stop codon at the end, so we have to search for one. Starting at the very next nucleotide, we're going to highlight until we see a typical stop codon. Our first one is going to be TAA, so we're going to copy that and add it to the end of the sequence in Xpasi to see if this stop codon is in frame. Since there's no stop at the end of this TAA is not in frame, so we're going to keep highlighting until we find another stop codon. In this case, it's TAA again, just slightly further down. So we're going to copy this sequence and again add it to the end of our ongoing sequence and hit Translate. This sequence was also not in frame, meaning that that is not our stop either. At this point, we're getting a little far away from the original end of the gene at 4073. We know that Mitos is very accurate when it comes to annotating the tRNA genes. So we can use these as a benchmark for where our genes should start and end. This tRNA gene here, tRNG, starts at 4056. So we know that the end of COX3 shouldn't be too far into this gene. Typically, you're looking for an end as close to 4056 as possible, but sometimes the stop codons can be as far as 40 nucleotides into this sequence. Since we're only roughly 20 nucleotides through, we're going to keep going. I'm just going to highlight a bunch of these all the way to here at 4138. This is actually completely past the end of this tRNA gene. And we're going to paste this in and hit Translate. There is still no stop codon, which means from the stop at Text Wrangler gave us, through this entire tRNA gene, there was no stop codon, meaning that the stop codon for COX3 is most likely an incomplete stop codon. So let's navigate back to 4054, where Text Wrangler originally said that our gene ended. So that's going to be right here. And we know that the tRNA starts at this G right here. Since we're assuming that COX3 has an incomplete stop codon, we need to choose a T that's as close to the start of this tRNA gene as possible. And that's going to be this T at 4055. So we're going to change this to 4055, add our T, and make a note that this is an incomplete stop codon. And this is our newly annotated sequence for this gene. Thank you for watching.